All right, number 22, test 2, section 4, here we go. And this one is another one of these, the two question problems where they're connected. So they're giving you this equation. There's a little paragraph that goes with it where they kind of tell you a large distance r, so r is your distance from a radio antenna, the intensity of the radio signal I, so I is your intensity. That's what that equals. Is related to the power of signal P. So the power of the signal is P. So you got all that stuff. They're just kind of telling you what the variables are. Now in 22, they got this little paragraph, but I want you to kind of skip that paragraph. Let's look at the answers real quick. What you'll notice is all the answers are solved for r squared. So this is nothing more than what we would call solving a literal equation, which means we're going to solve this equation for another variable. In this case, that variable is going to be r squared. So we're just going to do a little bit of algebra here. I'm going to write this as I divided by 1 equals P over 4 pi r squared. And I'm going to solve this for r squared. Now I did it as a proportion because we have a variable in the denominator. So I'm going to have to try to get it out. So what I use as a general strategy here, if the variable's on the bottom, I just set this up as a proportion and I use cross product property. Which means I'm going to multiply across here. So I have I times, which is really just all being multiplied anyway, 4 pi r squared. I've multiplied these two terms together, equals this cross product, which is 1 times p, or p. So I'm solving for r squared. So you'll notice all these terms right here, the I, the 4, and the pi, are being multiplied by r squared. So I'm going to divide by I 4 pi on both sides. That looks kind of really ugly looking, and you'll see the answer choices probably put the 4 in front, so that's what I'm going to do, the 4 pi. So I'm going to write this. Notice these all cancel. So you end up with r squared equals p divided by 4 pi times I, so 4 pi I. So we're looking for the answer choice that says that, which is answer choice B. So that's just solving literal equations. So again, proportions, that's one of the easy methods. If you have a variable in the denominator, you have to get out of it. So that's 22. 23. 23 is one where I actually use a method called plugging in. It's a strategy we use for problems that have variables in them that we want to get rid of. And that's what I'm going to do in this one. This one says for the same signal emitted by a radio antenna, observer A measures its intensity to be 16 times the intensity of observer B. So before I really get too far in this, I have two scenarios. So I'm going to go ahead and write scenario A and scenario B, or observer A, observer B. So I have two different situations going on here, so I can keep track of each set of data. And they're giving me a relationship between the intensity. So I know that the I, the value of I, is going to be 16 times greater on one than it is the other. So, and I'll explain to you in just a second why I know that this is a great plug-in problem, but let's first start plugging in and I'll kind of backtrack here. So I called I 16 and 1 because I can call it whatever I want, and I know that this one, they said in the problem itself that this number is 16 times greater than that number because the intensity is 16 times greater. The distance of observer A from the radio antenna is what fraction of the distance of observer B from the radio antenna? So what they're doing is they're asking for a fraction. So I'm going to call this what I call a fractional plug-in. This is one of the three methods that I usually use for students to let them know that, hey, this is a time where we could potentially plug in. If they're asking for fractions, there's a good chance you can plug in on this problem. This one's asking for fractions. By the way, the other scenarios, the problem has variables, it's algebraic expressions in the answer choices. There's a couple of scenarios where that will occur as well, and that's going to be what they use phrases like in terms of. If they use that, it's a good time to plug in. And they're asking about percentages. Now again, these are not foolproof. That doesn't mean any time you see a fractional problem or problem asked for a fraction that you have to plug in. It just means you can. Just like the other scenarios. It doesn't, just because they're saying in terms of x doesn't mean you have to plug in, but it's an option. So now that we have that out of the way, let's kind of go back to the problem, what we're trying to plug in. So we need to find r, because they're saying the distance of observer A from the radio antenna is what fraction of the distance of observer B. So that's my distance. So, I'm sitting here like, okay, well, I have to find these numbers. Well, I'm missing something because I need P. I have I need P, so we need to figure out what P is. Well, there's a little trick to this. Right at the very beginning, they said the same signal. If it's the same signal, it has the same power. The power of the signal is going to be the same, which means these two numbers right here are the same number because it's the same signal. So obviously a signal, when it initially emits, it's emitting the same power because it's the same thing. So we get to plug in whatever we want for P. But before we do that, don't just pick 1 or 2. Look at the equation. P is being divided by 4 pi. So a great number to pick for P is 4 pi. Normally you wouldn't pick a number like 4 pi, but look at that equation. That's a great number to pick because it's going to cancel out. Now I don't have to deal with the pi. You can call it pi by itself if you wanted to. It doesn't matter, but I like to also get rid of that fractional piece, the 4. So I have these two equations. I need to solve them both for r and then do what it says, which means I need to write the fraction and divide. So in this first one, I'm going to go 16 equals P, which is 4 pi. Now, just so you know, when you plug this in, I'm just going to plug in I equals, when I plug in 4 pi, just so I don't have to do it every time, this is what the equation is going to end up equaling. It's going to be equal to I equals 1 over r squared. So you can kind of see what I'm about to do. I don't want to plug that in every time and cancel it. So the 4 pi's are going to cancel. This is my new equation because 4 pi has been plugged in for P. So I'm going to go 16 equals 1 over r squared. Hey, look, another proportion. I'm going to cross product here. I'm going to put a 1 under the 16 to make a proportion. So I get 16r squared equals 1. Therefore, r squared, if you divide by 16, is 1/16. And r, if you square root both sides, becomes 1/4. Technically, it's plus or minus 1/4, but it's a distance, so it's going to be positive. So I have a distance of 1/4 for r. I'm going to do the same thing over here. I'm going to plug in 1. So I'm going to have, this is my equation, so I have 1 equals 1 over r squared. Remember, I plugged in the 4 pi, it just canceled. So here you can kind of do some simple math, like 1 divided by 1 is 1. So I already know r is 1. So that kind of makes it a little easy to kind of figure that piece out. So what they have us do now is the distance, so r for A, so observer A, that distance, is what fraction of the distance for observer B. So I'm just taking these two numbers, A divided by B. I'm going to just say A over B so you can keep track of it, but it's the R values for A and B. So those R values, that's 1/4 divided by 1, so we get 1/4. So my answer in this case is A, which is 1/4. So that is going to be number 23. So there we go with 23. That's a great one. That's a lot. I usually have a lot of questions on that problem, so hopefully that plug-in method can help you out on those types of questions. So 24, this is something that is very useful to know for the SAT because these tend to be harder questions and people don't remember the formula or the algebra required to solve these problems. But this is just asking you to convert from the general form of a circle equation to standard form for a circle equation, which means we're trying to get it into this form. X minus h quantity squared plus y minus k quantity squared equals r squared. That's what we want. We don't have that right now, but we can get there by doing something called completing the square. So I'm going to take this equation, I'm going to complete the square. So in order to do this, and by the way, if this is something, this algebra right here is too much for you, you don't remember it, this is something that you can very easily look up. I mean, obviously you're online right now. You can look up methods for completing the square and then come back and see what I did here, and it should make a little bit more sense. But I'm not going to teach the whole concept, I'm just going to show you how to apply it on this. So to complete the square, we got to do it twice. We got to do it to the x values and the y values. Once we've done that, they're asking in this case for the radius. So whatever the right-hand side equals, we square root that, and that's our radius. But we want to know how to complete the square and like actually do the whole process because 50% of the time they'll ask you for the center or the x or the y value of the center, or the they may ask for h divided by k. I mean, whatever the case, we need to know all the components. So anyway, let me start by putting the x's together. So I have x squared plus 4x, and then I'm going to put my y's together. Now as I do that, I'm going to have a little blank here. because I am going to complete the squared here in just a second. So I'm going to leave a blank before I write my y term. So that's plus y squared minus 2y plus blank. Now, whatever you do to one side, we are going to do to the other. So I'm going to also have two blanks over here. This is what really matters. Remember, we want that r value. So the process for completing the square, once you have these all arranged, this number that we plug in here is b over 2 quantity squared. Well, in this case, b, if you're thinking of ax squared plus bx plus c, this is my b value, that 4. So 4 over 2 squared is 2 squared. So we're going to put a 4 here and a 4 there. Because I added 4 to one side, I have to add 4 to the other. I'm going to do the same thing over here. This one I don't need to write the phrase b over 2 squared again. I'll just show you it's negative 2 over 2 squared. So negative 2 over 2 is negative 1. Negative 1 squared is positive 1. And then add it to that side as well. Now again, at this point, all I would care about is the right-hand side. These 1's cancel. We get 4. So I know that r squared equals 4. So r is 2. So your answer is going to be the radius of 2. However, on the left-hand side, if we were going to complete the square, here's what we should get. We should get x plus 2 quantity squared plus y minus 1 quantity squared. And that would be your left-hand side. So your center, in case they asked, the center is negative 2, positive 1. That's not what they want here, so I'm not really going to go much farther than that. But that's your center. This is your radius. They want the radius, which is 2. So that's going to be answer choice A. So that's 24. And again, I did that fairly quickly. But again, I'm letting you know it's completing the square. So that's the skill needed for that problem. Number 25. I got the information right here for you. So 25 says the graph of linear function. Linear function, I'm thinking slope, y-intercept, those concepts. Has intercepts at a0 and 0b. So they just gave me the y-intercept. That's always something important. And if a plus b is equal to 0 and a is not equal to b, which means that you can't have like a is 2 and b is negative 2. So they're not going to just cancel that way. Which the following is true about the slope of the graph. So when you're doing this problem, what you want to do, and if you look at the answers, you can't find the answer because I mean, I don't know what these numbers are. I don't really have enough information to be able to... oh, sorry, by the way, when I said that earlier, when I say A doesn't equal B, that just means that they can't both be 0. They have to be opposites. I'm sorry about that. So they have to be opposites, so it has to be like a 2 or a negative 2 or a 5 or a negative 5, but it can't be 0 plus a 0. So that's all they're saying there. These are two different points. They're not the same point of 0, 0. So if you're going to kind of try to solve this, what we do is do a little quick sketch and plug in some numbers. So let's say if a was positive, so that'd be a positive x value. So if a is positive, b, so this is say a positive 2, b would have to be a negative 2, so I'd have to go down 2. And if you drew that line, it would look something like this. So that's if I made a positive. What if I made a negative? Well, if I made a negative, well, b would have to be positive because I got to cancel. So I'm going to come up here and draw that line. And just, again, draw some sketches here and see what you get. Now, which of the following is true about the slope? A says it's positive. Well, yeah, it is. So I'll keep that. B says it's negative. Well, they're not negative. I can see that it's going up, so it's not B. It equals 0. No, it's going up. And D says it is undefined. Well, undefined would be a vertical line. Definitely not vertical, so it's not D. So your answer is A. Draw the picture, you should be able to see what's going on there. So that's going to be number 25. Let's keep it going here. Let's see, number 26. 26, they're giving you this graph and say which of the following are equal to 1. So I'm just going to do some evaluating here. So negative 4, I'm going to evaluate this and say, well, if I go 1, 2, 3, 4, again, this is your x value, and the output, that's going to be your y value. So if I plug in negative 4 for x, my y value is going to equal 1. So that one is equal to 1. We are good. Next, I have f of 3 halves. Well, 3 halves, that's about 1.5, so it's about right here. And it looks like I'm at 1 again, so that's 1. So I'm good again. Keep it going. If I go 3, so I'm going to go 1, 2, 3. 3 is at 1. Looks to me like these are all working. Every single one is at 1. By the way, these are the 3 points that I was looking at. So those are your 3 points. They all equal 1. So look like D says all of them. So your answer is D. So that's 26. So that's it for that one. 27. There's a lot of stuff going on here. So I'll try to simplify this down as much as I can. But they're giving you some graphs here, and they're giving you a lot of information about that graph, and there's a lot of words going on here. But I want to focus in on that second to last line in the question itself. Actually, the third to last. Let's read that whole last sentence. Which of the following statements correctly compares the average rates? So this is nothing more than a slope question, which isn't, because I have a graph, I'm going to think of it as rise over run. Again, when you got a really wordy problem, just go down to the end and say, what are they asking me? Because a lot of this information that's put into that question is describing that graph. And I don't really care about that, honestly. I just want to know what the question is. This is a rise over run question. It's just a bunch of lines, segments, and things like that. So which of the following correctly compares the slopes at which the temperatures of the two samples change? So if you look at the slopes here, and I'm going to try to do a couple of different colors to compare. I'm going to start with the circles, and I'm going to draw little lines here so you can kind of see how the slopes change. It looks like at first it's going down and it starts to kind of level off. So you can kind of see the rise over run. It starts as a bigger rise and run, but then it gets to be flat at the end. Whereas the boxes, they're going down. It doesn't look like as fast, but it is fairly consistent. If you look, it kind of levels off maybe a little bit at the end, but it looks like it's still going down a little bit. So I kind of have some idea of what's happening, so I can start comparing my answers. So I'm going to go through my answer choices now and do some process elimination and see what I get. So A says in every 10-minute interval, the magnitude of the rate of change, so how big it is. And by the way, when I look at this, the insulated, that's going to be, and I'll put an I here. So, oops, I should probably color code this a little bit. So that's my I, which is insulated, and the pink is the non-insulated, so I don't have to keep going back and forth and looking. So in every, and that's a big scary word too, in every 10-minute interval, the magnitude of the rate of change of temperature of the insulated sample is greater than that of the non-insulated. So they're saying that the square has a bigger slope always, no matter what. Well, it looks at first like this pink one, the non-insulated, had a bigger slope at first. So that would probably mean no, that's not every interval. So I'm going to eliminate A because that doesn't seem to hold true. So A is gone. It just didn't do what it said. B says in every 10-minute interval, the magnitude of the rate of change of temperature of the non-insulated sample is greater than that of the insulated. So they're saying non-insulated always has a bigger slope. Always. Always, always, always. Here at first, yes, it does have a bigger slope at first. But remember at the end where I said it almost gets flat? Well, this one's going down, not by much, but this one's going down and this one's not. So they're saying, that it always has a greater rate of change, which at the end it doesn't. So the pink one doesn't have a greater rate of change at the end, so B is wrong. So next up we have C. And if you look at C and D, let's just jump down to the answer so we can just get to it. So the answer is going to be D here, and let's kind of talk about why. So in the intervals from 0 to 10 and from 10 to 20, the rates of change of temperature, the non-insulated, so pink, are of greater magnitude. So at first it's at a greater magnitude, which is true. It is at a greater, it's slightly going down a little bit faster. Whereas in the intervals from 40 to 50, 50 to 60, the rates of change of the insulated sample are greater magnitude. Well, remember this, notice at the end here, this right here, it got to be almost 0 basically, and this one's going down. So while this one had a greater rate of change, at the end, the insulated had a greater rate of change. So this one holds true for both domains. So your answer choice that you should be picking is D for number 27. So that's a lot of words and things like that, but again, it's just a rate of change problems, rise over run. So lastly, we got 28, giving us this picture here. I was kind of surprised I got it to look somewhat accurate. I drew that by hand, eyeballing it, so I'm pretty impressed with myself. But anyway, enough about me. This one, they're giving us some points, and I should just go ahead and label those here, which I'll do now. They're giving us the points, the coordinates of points C and E. So C is 7, 2. And E is 1, 0. All right. So we got those points. Which of the following is the equation of the line that passes through points B and D? So 28, they're asking for an equation of a line that goes through, again, B and D. So they're looking for the equation of that line right there. Well, first off, they're talking about equation of a line, so I'm thinking y minus y1 equals mx minus x1. That's the equation of the point slope form equation for a line. So with this being said, I have a point. I can just pick one. I'll pick the point 1, 0. Seems good to me because E goes through that line. And from there, I just need to find my slope. And if you're really looking at this, honestly, even though they're not giving you these points, there's a couple ways around this. I mean, they kind of make it so you can figure it out either way. Here's how they're trying to get you to figure it out. That's perpendicular. I mean, this looks like, and it's a square, they told you. So the diagonals are perpendicular. That's the geometry behind this. The common sense behind this is point B. I mean, just look at that point. It looks like it's at -1, 6. So I'm going to say -1, 6. I mean, and you're probably right. Even if you're not, you're going to be pretty close, and you can check your answer choices and figure it out from there. So I'm just going to do that method instead of doing the perpendicular slope and things like that. So I'm just going to go down from B to E. I'm going to go down 6, so -6. That's my rise. My run is from -1 to 1. So that's going to be right 2. So that's -3. And notice that's actually the slope on some of the answer choices. So yeah, I'm just going to check my answer choices now. I got my point and my slope. So I'm going to go y minus y1. Well, y1 is 0 equals m, which is -3, x minus x1, which is x minus 1. And I want to see what answer choices matches that. I doubt I have the y minus 0 in there, so maybe I'll just have this. Or they'll put it into slope-intercept form. It all depends. But no, look, if you look at it, it looks like B is matching this. So you just pick your answer. So that is your answer for number 28.